Dear students, welcome to the class. In the previous videos, we have studied about the inverse of the function and how to get the domain and principal value of the inverse of the function. Today, we will discuss about properties of inverse trigonometric function. For you, you have 6 properties. In that, each one contains a sub-properties. Like this is one property. This is a reciprocal. If you take any inverse function with the element as a reciprocal of x, then it is the reciprocal function of the inverse function. For that, there are 3 inverse functions. Sine inverse of 1 by x. The answer is cosecant inverse of x. Second one, cos inverse of 1 by x is equal to secant inverse of x. And third one, tan inverse of 1 by x is equal to cot inverse of x. This is one property of the inverse function. See, we know we have sine x and the cosecant x is the inverse of the sine x. Right? The cosecant function is the inverse. The cosecant function is the reciprocal of the sine x function. So we can observe here the function inside the inverse function is reciprocal of the x, and in the right hand side we are getting the reciprocal of the sine x and the reciprocal of 1 by x. Right? So this kind of property which is involved in first property. Let me prove this. How to prove this? First, I will consider the right hand side cosecant inverse of x as y. Okay? While applying cosecant function to this and the other side, then it becomes x which is equal to cosecant y. Okay? Or else, in general, you can say that cosecant inverse function, if we shift to the other side, it becomes the cosecant function. Other side of the right hand equal side. Here, cosecant inverse x is equal to y, which implies x is equal to cosecant y. If I take reciprocal on both sides, 1 by x is equal to 1 by cosecant y. Right? In the place of x, we have cosecant y. Okay. We know 1 by cosecant y is equal to sine y. Right? The reciprocal of cosecant y is a function sine y. Therefore, 1 by x is equal to sine x means sine inverse of 1 by x, which become y. Right? Sine inverse, if we shift the sine function to the other side, it becomes sine inverse of this 1 by x. The remaining here it is y. We know the y is nothing but cosecant inverse of the x from the equation 1. If we substitute that cosecant inverse of the x in the equation number 2, then it will give sine 1 by x is equal to cosecant inverse of the x. This will prove our first property which contains sine inverse function. Clear? I will explain one more time. I am choosing the right hand side of this expression, cosecant inverse of the x is equal to y, taking that equation as 1. And if I apply cosecant function both sides, this becomes the identity function. It will give us x. And here, while applying cosecant to the y, it becomes cosecant y. I am taking the reciprocal of 1 by x. Since I am taking reciprocal of x as 1 by x or 1 by x, then I have to take the reciprocal of the cosecant y. Right? It is 1 by cosecant y. From the property of the cosecant function, 1 by cosecant y is nothing but the sine y. The reciprocal of the cosecant y is the function sine y. I am substituting that. So 1 by x is equal to sine y. If I apply sine inverse on both sides, in the left hand side becomes sine inverse of 1 by x. In the right hand side becomes sine inverse of sine of y, that is nothing but the identity function. It will give us y. Or simply, if we shift sine function to the other side of the variable, then it will become a sine inverse function. So sine inverse of 1 by x is equal to y. From the equation 1, y is nothing but the cosecant inverse of y. I am substituting this y as cosecant inverse of y. That is our required condition or required equation. Right? Therefore, this is sine inverse of 1 by x is equal to cosecant inverse of x. If you calculate sine inverse of 2 by pi, which is same as cosecant inverse of pi by 2. Instead of finding the sine inverse of 2 by pi, we can find cosecant inverse of pi by 2. Why? 2 by pi, I can write 1 by pi by 2. Right? 1 by pi by 2. So, cosecant inverse is nothing but 1 by x or 1 by x idre cosecant x irtade. Here 1 by pi by 2 means in the cosecant inverse it should be pi by 2. Cosecant inverse of pi by 2. This is one of the example. Okay. Same way we can prove the second thing, the first property where cos inverse exists. That is, cos inverse 1 by x is equal to secant inverse of x. Same procedure I am following. Taking secant inverse of x as y, then x is equal to secant y, and I am taking reciprocal of x. It becomes 1 by secant y. 1 by secant function is nothing but the cosecant or cos function, cosine function, right? 1 by x, which is 1 by secant inverse, it's y is equal to cos y. 1 by secant y is equal to cos y. And if I exchange the function, it becomes cos inverse of 1 by x, which is equal to y. Y is nothing but from this equation, y is nothing but secant inverse of x. So cos inverse of 1 by x is equal to secant inverse of x. This is the proof of the second part of the first property. Clear? The same procedure I am following as I did in the case of sine inverse. Next one, the third part. Here we have tan inverse function. We will follow the same procedure. Cot inverse of x as y, and x is equal to cot y. Take this as equation number 1, the first expression, and after that take reciprocal, because here we require reciprocal of 1 by x. So it is 1 by cot y, 1 by x. The reciprocal of cot y is equal to tan y. Okay. Therefore, if we shift the function, it becomes tan inverse of 1 by x is equal to y. Take this as equation number 1. From 1 and 2, tan inverse of 1 by x is equal to cot inverse of x. This is a simple proof for sine inverse of 1 by x is equal to cosecant inverse of x, cos inverse of 1 by is equal to secant inverse of x, tan inverse of 1 by x is equal to cot inverse of x. In the second property, we have sine inverse of minus x, tan inverse of minus x, and cosecant inverse of minus x. The first part of the second property is sine inverse of minus x is equal to minus sine inverse of x. We should know to prove this these three conditions, because here we require sine inverse of minus theta is equal to minus sine theta. This condition we already proved in our first PO class, which tells us if we want sine inverse of minus 90 degree, it is enough if we know sine 90, and for that value, if you use negative sign, that will be the answer. Sine 90 value is 1. Instead of finding minus 90, it is enough we know the sine 90 value, that is 1. So sine of minus 90 is equal to minus 1. Right? We are using this condition for this purpose. Same way, sine inverse of minus x is equal to minus of sine inverse x. If we need sine inverse of minus of any angle, then it is enough if you know the sine inverse of that angle. From that, if we add negative sign to that answer, to that value, then it becomes the sine inverse of minus x value. Let me prove this expression, this equation. And you should know this condition only for its principal value. Here sine inverse function which has the principal value minus 1 to 1. Tan inverse function which has the principal value the set of all real number. Cosecant inverse of the function which has the inverse value all the real number except minus 1 to 1. This is nothing but x should be greater than or equal to 1 or x is less than or equal to 1. This modulus means x should be greater than or equal to 1 or x should be less than or equal to 1, which is same as x belongs to the real number set except minus 1 to 1. Clear? These conditions only in the principal value branches. So let me prove the first one, first part of the second property. Let me take this sine inverse of the x as y, the left hand side expression as y, then I have to get this equation. So let me take sine inverse to the other side, or applying sine function to the other side. We know applying sine function means we are applying sine function on both sides. It will be like this. Okay, if sine of sine inverse, it is nothing but the identity function. Identity function means it will return the same value. So it is minus x is equal to sine y. This is the actual procedure is going on. So that here it is minus x is equal to sine y. Then I will shift this sign to the other side, that is minus sine y. If we take minus x value is 1, means x is equal to minus 1. Right? The same procedure I am considering here. Minus x is sine y implies x value is minus sine y. From this property, look at here, minus sine y minus sine theta. Minus sine theta which is equal to sine of minus theta. So anyway, minus sine y which is equal to sine of minus y using this property, using the sine function property. So that if I shift again sine function to the other side, it's like this, sine inverse of x is equal to minus y. Right? Here I am applying sine inverse function to the others, on both sides. Sine inverse of x is equal to sine inverse of sine of x. Sine inverse of sine of minus y become minus y. So after that, let me take minus to the other side. Minus sine inverse of the x is equal to y. From this equation, I can substitute y as sine inverse minus x. Therefore, from this expression, sine inverse minus x is equal to minus of sine of x, minus of sine of x. I can write this like this, sine inverse of minus x is equal to minus of sine inverse of x. Clear? I will explain this one more time. Sine inverse of minus x, I am taking it as y, and applying sine function on both sides, it will be minus x is equal to sine y, and shifting the negative sign other side, x is equal to minus sine y, x is equal to sine of minus y because of this condition. Okay, so again I am shifting sine function to the other side, that or applying sine inverse on both sides, then it becomes sine inverse of x is equal to minus y. Again I am shifting the negative sign to the other side, minus sine inverse of x is equal to y. I am substituting y as sine inverse of minus x because we are considering sine inverse of minus x as y. So y is equal to sine inverse of minus x, and y is also equal to minus of sine inverse of x. Therefore, sine inverse of minus x is equal to minus of sine inverse of x. Clear? So that this is a proof of the first part of the second property. Next, similarly, we can prove the second part of the second property. In that, we have tan function. Let me take tan inverse of minus x as y. Take this as equation 1. Minus x is equal to tan y, and x is equal to minus tan y, shifting sign to the other side. We know minus tan y is equal to tan of minus y. I am applying that property of tan function. Then shifting tan or applying tan inverse on both sides, it will be like this. I am shifting negative sign to the other side. It is like this. So that from this two, the right hand side are same, so that the left hand side also same. Tan inverse of minus x is equal to y, and y is equal to minus tan inverse of x. Therefore, tan inverse of minus x is equal to minus of tan inverse of x. Simple, isn't it? Next, similarly, we can prove for the cosecant inverse of minus x, and the answer is minus of cosecant inverse of x. So first, if we will take minus cosecant inverse of x as y, and applying cosecant function on both sides, it will be minus x is equal to cosecant y. Shifting negative sign to the other side, it will be x is equal to cosecant y, and we know minus of cosecant y is equal to cosecant of minus theta. So I am applying that here. X is equal to cosecant of minus y. Again, applying cosecant inverse function on both sides, it becomes minus cosecant inverse of cosecant inverse of x is equal to minus y. Shifting minus sign to the other side of the right hand side, it will be minus cosecant inverse of x is equal to y. And from these two equations, the right hand side are same, so that the left hand side also same. That is, cosecant inverse of minus x is equal to cosecant inverse of minus of cosecant inverse of x. So that cosecant inverse of minus of x is equal to minus cosecant inverse of x. You should know all these properties for sine inverse, tan inverse, and cosecant inverse of minus x. It is obvious when this function in its principal value branch. Sine inverse of minus x is equal to minus sine inverse of x if and only x lie between minus 1 to 1. Similarly, tan inverse with this principal value branch and cosecant inverse of minus x is satisfying this property when cosecant inverse lie in the principal value branch. In the third property of the inverse trigonometric function, we have cos inverse function, secant inverse function, cot inverse function. In the previous property, we have sine inverse, cosecant inverse, and tan inverse. In those function, the minus of the value is equal to the direct minus of the function inverse value. But here there is a change. Cos inverse of minus x, which is not equal to minus cos inverse of x, it is pi minus cos inverse of x. For example, if we require cos inverse of minus 1 by root 2, okay, at the time we have to get cos inverse of 1 by root 2. The value is, we know, pi by 4. Cos 45 is 1 by root 2. So that for this is not equal to minus pi by 4 as in the case of sine cos. It is equal to pi minus pi by 4. That is 3 pi by 4 is the answer for cos inverse of minus 1 by root 2. We will see all these problems in the next upcoming videos. But we should know these properties. Cos inverse of minus x is equal to pi minus cos inverse x. Secant inverse of minus x is equal to pi minus secant inverse of x. Cot inverse of minus x is equal to pi minus cot inverse of x. To prove these, we require these three properties of inverse function. Cos of 180 minus theta or cos of pi minus theta is equal to minus cos theta. Secant of pi minus theta is equal to minus secant theta. Cot of pi minus theta is equal to minus cot theta. Let me prove the first one. Cot inverse of minus x, I am taking this as y and shifting cot inverse or applying cot function on both sides, it will be cot of cot inverse of minus x is equal to cot y. Cot of cot inverse is identical function, it will return minus x as it is. In this case, the changes is the right hand side, the changes is cot y. So this x is equal to minus cot y, shifting or changing the sign on both sides. And I took the third expression first, cot y. So minus of cot y is cot of pi minus theta, right? Minus of cot y is cot of pi minus y. So I am using that property. So it will be cot of pi minus y. Again shifting cot to the other side, cot x is equal to pi minus y. From this equation 1, the value of y is cot inverse of minus x. So cot x is equal to pi minus cot inverse of minus x. We got like this. But we want cot inverse of minus x is something, right? Here we have cot of x is something. Let me rearrange this. First I will shift this to this side, that is cot x plus cot inverse of minus x minus cot inverse x, it becomes plus cot inverse of x if we shift that to the left hand side of the equal sign. It's equal to pi. Then in the left hand side we require cot inverse of minus x. So I will shift this function to the other side. It becomes cot inverse of minus x is equal to pi. The sign of the cot function cot x is plus, so minus cot x. Cot inverse of minus x is equal to pi minus inverse of x. Here I made one mistake. Every time here we shift cot to the other side, it becomes cot inverse of x. So here we have cot inverse of x. So that cot inverse of minus x, which is equal to pi minus cot inverse of x. Similarly, we can prove for cos and secant inverse. Quickly we will prove. Okay. So cos inverse of x is equal to, I am taking as y, x as cos y, cos inverse of minus x as y. So minus x as cos y, x is equal to minus of cos y, x is equal to minus of cos y is cos of pi minus y. So again cos inverse of x is equal to pi minus y. So cos inverse of x is equal to pi minus y is nothing but cos inverse of minus x. Changing their positions, it becomes cos inverse of minus x. Here it is minus sign, it will be plus if we shift to the left hand side of the equal sign, and pi, here it is, the sign is plus, so that if I shift to the right hand side of the equal sign, it becomes minus cos inverse of x. This is our required equation. Similarly, we can prove for the secant inverse of x. Secant inverse of minus x, it takes as y, minus x is equal to secant inverse of y, and x is equal to minus of secant inverse of y, and x is equal to minus of secant inverse of y is equal to plus secant inverse of pi minus y. So it is secant inverse of x is equal to pi minus y, or secant inverse of x is equal to pi minus y is secant inverse of minus x. So shifting order or rearrange the thing, it is secant inverse of minus x is equal to pi minus secant inverse of x. Clear? Like this, we can prove these three subparts of the third properties. In the fourth property, the first subpart is sin inverse of x plus cos inverse of x, which is pi by 2, that is 90 degree. If you take any x, sin inverse of x plus cos inverse of x, the value is 90 degree. For example, sin inverse of 1 by root 2 plus cos inverse of 1 by root 2 is equal to pi by 2. Directly you can say. Or sin inverse of root 3 by 2 plus cos inverse of root 3 by 2 is equal to pi by 2. If you take any x for sin inverse and cos inverse function, then sin inverse of x plus cos inverse of x is equal to pi by 2. This is because in this sin and cos function, the connection between sin and cos function is sin theta, which is equal to cos of pi minus 2 minus theta. And sin theta, which is equal to, if we change sin to the cos function, then we have to change the angle to 0 to 90 degree. Sin ಯಾವ್ದು ಆಂಗಲ್ ಉಂಟು ಅದರದು 90 ಡಿಗ್ರಿ ಅದು ವೇರಿಯೇಷನ್ ಅಲ್ಲಿ ನಾವು ಆಂಗಲ್ ಫೈಂಡ್ ಮಾಡಿ ಅದರ ಕಾಸ್ ವ್ಯಾಲ್ಯೂ ಆರ್ ಒನ್ ಅಂಡ್ ದಿ ಸೇಮ್. sin 45 is equal to cos 90 minus 45 or 45. sin 30 cos 90 minus 30 60. So sin 30 value is equal to cos 60. Same way, because of that we are getting sin inverse of x plus cos inverse of x is equal to pi by 2. We will prove this. And one more thing, I will prove the first one. The two other expression that you have to prove, that is your exercise problem. So I will prove first one, sin inverse of x plus cos inverse of x is equal to pi by 2. And most of our in the final examination we require to prove the one of these three equation or some other property of the inverse trigonometric function. That is just your question for 2 marks. Okay, 2 marks question. Either fourth property or 1 to 3, or out of 4 property you will get at least one property for final examination to prove the properties. So this one, to prove this, sin inverse of x I am taking as y, and x is equal to sin y, applying sin on both sides. So I am converting sin function in terms of cos function, that is, which is same as cos of 190 minus pi, or pi by 2 minus y, 90 minus y. So this x is equal to cos of pi by 2 minus y. If I apply cos inverse, then it is cos inverse of x is equal to pi by 2 minus 5. I will shift this y to the other side, minus y, it becomes plus y plus cos inverse of x is equal to pi by 2, but we are substituted y as sin inverse function, so it is sin inverse of x plus cos inverse of x is equal to pi by 2. This is a proof of the sin inverse of x plus cos inverse of x is equal to pi by 2 using this condition or this equation. Sin theta is equal to cos of pi by 2 minus theta. So sin y is equal to cos of pi minus 2 minus y. The rest, the other two properties that you have to prove, and with this we already proved 4 properties. The remaining two properties we will do in the next class, and some of the problems related to this property also we will solve in the next class. Before going to the next class, we should know all the properties of inverse trigonometric function and the principal value to get the principal values of the inverse trigonometric function. Okay, study well for the next class. Okay, thank you so much.